Hello, and welcome back. This video is about building the base weapon logic with enemy facing. And a special thanks to all my supporters. Thank you for helping me help others. So the first thing I've done is copy the weapon and ammo FBX files from Kenney's Tower Defense Assets into this folder. We'll click on Import. We want our uniform scale as 1. The rest of this should be fine. If you need a reminder on how this is all done, video 11 in the series is a good place to check. So with that all done, you can see that there are 4 ammo: weapon ammo, arrow, boulder, bullet, cannonball. But you can see that there was 1 FBX for the ballista, the cannon, the catapult, and the turret, but each of those FBX has 2 meshes in it. So we effectively have a top and bottom for each of our weapons. So we're going to build the tower based on that. So we're going to have our towers in each of these spots, and for each individual tower, effectively it's going to be trying to fire at the enemy that's along the path at the furthest point along that path. So being that the wave manager is the component that owns all of our enemies, we'll go in there to create a function for that. So in here, we're going to create a function. I'm going to call this Get Furthest Enemy. Could be furthest along or a max, high distance or something like that. But effectively what we're doing here is we're taking our enemies. We're going to iterate through that. So first we need to check if this specific enemy is within range of the tower. So to do that, we're going to send along 2 variables, a vector location and a float radius. So we want to take our enemy, we get our actor location. We're going to be checking the distance, and we can use distance 2D. This will ignore the Z value you can see there. And that's being compared against our location we sent in. And we're checking to see if that distance is less than or equal to the radius we just sent in. In the case where this is a valid enemy in range, we want to get to the dist value that we have in our enemies, which represents how far along the path they are. We'll take that, we'll use that to promote to a local variable. We'll call this the high dist. And as long as the dist of the enemy is greater than the saved high dist, then this enemy is now the one that is furthest along the path that has been found. When that is the case, we want to save that dist as the high dist, and we also want to save the current enemy. We can call this one high enemy. And I'm just going to clean this up a little bit. When this loop is completed, we'll just return our high enemy. So this function could be called by the tower or the weapon on the tower. but it's currently just in Wave Manager. So the question is, how do we get access to this function from there? So for that, I'm going to create a utility function in our function library. This will be Get Wave Manager, not Waver Manager. So for now, each map would just have one Wave Manager. I'm going to call Get All Actors of Class, and we're just looking for the Wave Manager. So as you can see in the note here, this is a slow operation. You don't want to use it often. However, for the ease of use of this video, we're going to go with this now. We can cache this value later. The problem is we can't cache it or save it in this function library because it has no data. So once we've gotten all the actors, which we know is just going to be the one, we can just check to make sure that it's not empty. And we want to get the first entry. I'm going to add another return node so that we can output a Boolean for isValid and the Wave Manager object itself. In the case where it can't find it, then we just return null or none and false. So next I'm going to create just an actor blueprint. This we'll just call BP weapon. In weapon, we want to just add 2 static meshes. We'll call this one bottom. And top. They don't need to be hierarchical, but it shouldn't really matter. With this class created, we can then right-click, create child actor, or child blueprint class, that's an actor. We'll call this one BP turret weapon. And in here, we're going to set the bottom static mesh to weapon turret, weapon turret. And the top will be weapon turret barrel. You can see with the way the mesh is created, it has the top set in the correct position. So we don't need to worry about that. As we'll see later, however, the models were created along the y-axis here, and we want them along the x-axis. So back in our weapon blueprint, during tick, we're going to want to call 2 functions. So we'll first call find enemy, and then face enemy. These can just be called from tick. And find enemy, not surprisingly, is going to call the get wave manager we just created, verifying that that is valid. We can then call Get Furthest Enemy, and we're sending along our actor location. And for now, we can just set the radius to 200. Meant to rename that variable, just go in and do that. Just call this enemy here. And we're just saving this as target, as a variable, not local variable. In our face enemy, we're going to grab our target, convert it to a validated get. We're going to use the utility function find look at rotation. We do not want the Z values to change, so we'll split these out. The start location is the actor location for this weapon. And the target is going to be our target. And with that, then we can call set actor rotation. And lastly, we need to add this to the towers themselves. So in our tower base, we're going to add a child actor component. This is effectively the way that Unreal nests, well, one of the two ways that Unreal nests child actors. I'm going to call this child actor weapon. So as stated, this is one way. We have our child actor here. We set our child actor class, which we don't need to do in our tower base. But in our turret tower, we go in here and we select our turret weapon. Now, if we look at the viewport, you can see that it's not there. So that is because it's starting out at the same Z location. We just want to pop this up 80. I'll just reset this to 0. There we go. So if we go in and demo this, we'll throw in a tower here. You can see that the turret is not facing anything. Let's fix that. So we'll start in our weapon blueprint and trace back from there. So we have our find enemy that looks fine. It's calling Get Wave Manager, checking the is valid condition, using that to call the function to set the target. The target is then used here. Assuming that's valid, then it rotates towards it. So in our find enemy, we're calling Get Wave Manager. So we go in here. We can see that it's getting all actors of class. Assuming it's true, it branches, and then we return false in both cases. So maybe you caught that, but that's the solution here. So with that running, we'll start another, pop out a few towers. You can see it starts facing when it gets in range, but as I stated, the angle is off by 90 degrees. You can also see it's snapping. As soon as one's out of range, it's snapping right to the one past it. So we can fix those, or at least fix the one and adjust the other. So the rotation issue, we can just go in here and we can rotate either of these two. The bottom on the turret, it doesn't really matter. It kind of makes sense that the top would be the portion that's turning. But in the case of the other weapons, you're going to want the base, the bottom of these two, to be turning. Well, these three. So in that case, we can take our bottom here and rotate this -90. Run that. So now it's facing them correctly. The snapping we can fix with our face enemy. Instead of setting our actor rotation as the look rotation immediately, we can call lerp for the rotator instead. And in that case, the value here is our destination, and the starting point is going to be our actor rotation. And then alpha here is the term that's used to determine how quickly it goes. We'll just set this to 0.1. You can still see it moves quickly, but it's not snapping. Got a little bit more. You saw the spin there. Spin, however, we can fix by just checking the shortest path. Thanks for watching. If you liked the video and would like to see more, you know what to do. And if you would like to support this channel, watch these videos 2 weeks early, or just want to download the project files, you can do so through my Patreon linked below.